Good afternoon. Let's go ahead to get started. Welcome to our seminar today. My name is Yang Zhang. I'm a professor in Civil and Environmental Engineering, Northeastern University. I'm the organizer for today's seminar. And in light of growing convergence research, we established this new monthly Lunch and Learn seminar series to provide a forum to bring together leaders, engineers, and researchers from academic, industry, nonprofit, and government to promote and realize the concept and approach of convergence and its application to engineering, science, technology, and product, to explore cross-disciplinary, sub-disciplinary collaboration and foster the transformative innovation by thinking big and bold, by acting fast and passionate. We are here to share successful story and lessons learned from convergent research to build a culture of team working and convergent research environment. All of those will help us nurture future global convergence, a leader in engineering and science from now and here. What is convergence? Based on NAE's report published in 2014, it is defined as a problem-solving approach that cuts cross-disciplinary boundaries, facilitating transdisciplinary integration of life science, physical sciences, engineering, and beyond. And the NAE report in 2017 defines convergent engineering as a deeply collaborative, team-based engineering approach for defining and solving important and complex societal problems. The NSF Engineering Research Center call for proposal further define convergent research as a high-risk, high-payoff research ideas and discovery that pushes the frontiers of engineering knowledge. That would lead to large positive societal impact, has a strong potential to lead to transformative solution or even new field of study. We are in a world that requires convergence more than ever. From NSF's big ideas on growing convergence research that comes with millions of dollars funding to support various research programs, to individual universities' seed funding or fundraising to transform research into innovative technology breakthrough. We have seen enormous funding opportunity and collaboration opportunity for convergent research. There have been increasing number of large convergence research centers, both in US and worldwide, which leads to explosive generation of convergent knowledge, technology, books, and other resources. The Department of Civil and Environmental Engineering at Northeastern University plays a vital role in this world of convergence. As you can see here, urban engineering is our focal point, forming the foundation of three main thrusts in our department, including civil, infrastructure, security, environmental health, and sustainable resource engineering, which are further supported by our 7 disciplines, as highlighted here. The nature of our research requires multidisciplinary, interdisciplinary, transdisciplinary knowledge and collaboration through integrating computer simulation, smart sensing, urban informatics, and data and network science to create convergent product that would have large societal impact. We are in a unique position to become a convergent research incubator to develop and shape our own convergent research agenda and legacy. What would be the successful recipe for convergent research? Collaboration, integration, innovation, and many more. You can define it from now and here. With that, it's my great honor to introduce our inaugural seminar speakers, Dr. Auroop Ganguly, a professor of our department, and his former PhD student, Dr. Evan Kodra, a CEO of risQ. And they both are the co-founder for this risQ, that's a Boston-based spin out of Northeastern University, famous sustainability and data science lab that's being led by Professor Ganguly. They are here to share their successful story on convergent academic research to socially motivated startup using risQ as example. Dr. Auroop Ganguly is an internationally recognized expert at the nexus of climate risk, water sustainability, infrastructural resilience, artificial intelligence, and nonlinear dynamics. He is a fellow of American Society of Civil Engineers, a senior member of Institute of Electrical and Electronics Engineering, as chief scientist in DOE's Pacific Northwest National Laboratory. He received his bachelor degree in civil engineering from Indian IIT, a master degree also in civil engineering, University of Toledo, and also a PhD degree in civil and environmental engineering from MIT. His career spans from academia to private sector and governmental lab. He has served in numerous capacity in the climate community, also receiving many awards, such as Best Paper Award in Top Tier AI venue. He has published many papers in high-impact journals like Nature and PNNL. He's widely cited by the United Nations and U.S. National Climate and Environment Assessment Report. In addition, he served on those high-impact panels. He is the major inventor for 2 U.S. patents, one on climate risk and the other on infrastructural resilience. Our second speaker, Dr. Evan Kodra, is our proud alumnus. He holds a PhD degree in interdisciplinary engineering, also a master and bachelor degree both in statistics and both from University of Tennessee. He is a rising industry leader specializing in statistic modeling of uncertainties in climate change risk, extremes and tail risk, as well as a structural incentivization for climate action. Dr. Kodra also published in high-impact journals, and he serves as a panelist for Boston Resilience Advisory Group Green Ribbon Commission webinar. He is leading temperature science team for the Climate Ready Boston Initiative. In addition, he is also a major innovator for the 2 U.S. patents. With that, I will hand over to our first speaker, Dr. Auroop Ganguly. Thank you.
Thank you so much, Yang, for the kind introduction, and hello to everyone else. I am Auroop Ganguly, and David, if you could please put our presentations online. Thank you so much, David. Thank you so much, David. So let me start with a quiz. I have some pictures for you. So the picture on the left was taken with my cell phone's dual camera. The picture on the right was taken during one of our safaris. How many of you can tell me the geographic location of this? So I'll come back to this at the end. David, next slide, please. So the World Economic Forum comes up with a global risk report every year based on the perception of their attendees. What we see here is a summary of the risk from their 2020 report. Now, risks can roughly be thought of as a likelihood, which is shown on the x-axis of the left graph, and which represents the chance of an event happening, multiplied by the impact, which is shown on the y-axis of that graph. And this is the damage that's expected to occur if the event happens. So when we look at the top right, we see the risks that are perceived to be very high, even among the global risks of highest concerns. This top right space is dominated by weather extremes and climate action failures, and biodiversity loss and nature or environmental disasters and water crisis. When we look at the other important set of risks, they include failure of urban planning and information infrastructure, targeted attacks such as cyber and terrorism, as well as data fraud and governance failures. So our research at the Sustainability and Data Sciences, or SDS Lab, intersects many of these challenges, specifically weather extremes and climate change, as well as hazards, water and critical infrastructures, and urban sustainability. In addition, we use a combination of tools such as physics models and computer simulations integrated with data sciences and artificial intelligence. Next slide, please. So the Earth system sciences and engineering offer an interesting example. Understanding of physics and biogeochemistry, as it's called, across couple land, atmosphere, ocean, ice systems, and computer models or simulations that encapsulate this understanding has been considered the state of the art. Data sciences, such as statistics and nonlinear dynamics, have been used in conjunction with such models and physics. These models and data have helped us understand global warming, regional changes in climate and hydrometeorology, and extract insights such as variability of heat waves, and somewhat counterintuitively, persistence of cold snaps in a warming environment, which was a paper led by Kodra, from whom you'll hear soon. However, there have been discussions that science advances have not been able to keep pace with the urgency of stakeholder requirements. So while artificial intelligence has often stepped in and out of the limelight over the last few decades, recent successes of methods such as deep learning appear to suggest new possibilities for a variety of science and engineering disciplines, including earth system sciences and engineering, civil and environmental engineering, among others. A recent perspective article in the journal Nature, which is considered the world's top interdisciplinary journal of science, provided 4 examples from the AI and earth systems literature to showcase how advances in AI, together with process understanding, can be leveraged to make significant advances. One of the 4 examples in is our recent work, which was done collaboratively with NASA, led by my former PhD student, Thomas Vandal, who was co-advised with Evan Kodra. So in which artificial intelligence, specifically deep learning advances in computer vision, were first adopted and then adapted and finally innovated upon to try and address a pressing gap in science and our ability to translate the science to adaptation and planning. What this initial work showed is that there may be value to exploring this area further. Next slide, please. So beyond understanding the science and extracting insights from past data and making projections about the future, there's a need to predict and manage risks. So on the left here, what I show is a risk framework in a climate context, especially with a focus on water. So a hazard like hurricane or heat waves or heavy rain or drought, which may all be impacted by human activity in various ways, becomes a catastrophe only when supplemented by vulnerabilities such as fragile infrastructures and exposure such as disadvantaged people and economic assets being in the path of maximum damage. Risk management includes emergency management, including preparedness, consequence management, and recovery, as well as longer-term adaptation and mitigation. Different strategies, including a diverse suite of physics-based computer models, as well as data-driven sciences, including artificial intelligence, broadly construed to include machine learning, network science, nonlinear dynamics, etc., can help in this process. So here we show on the right how water models at different scales and with different focus are used to address a diversity of risk management problems related to water. Thus, at the top, land models within comprehensive earth system models help us understand strategic issues like impact of anthropogenic emissions on regional land use change, on water resources, including water quantity and quality, and the expected statistics of flood or drought extremes, as well as impacts on the water, food, energy nexus at larger scales. However, operational use-specific models like the National Water Model, or at least the aspiration of what this National Water Model will hopefully become, help us predict and deal with floods and drought hazards. A third type of model, such as WEEP and LEAP on the bottom right, help in tactical decisions, including water adaptation, such as operations of dams and reservoirs, as well as mitigation and energy policies. Next slide, please. So critical infrastructures, whether at community or city scales or at mega region and national or even global scales, are aging and often crumbling and getting stressed from changes in climate and population at local, regional, and global scales. Lifeline networks such as water distribution or wastewater systems, land, sea, air, water transportation networks, power grid and energy pipelines, as well as communication systems are interdependent on each other, suffer from cascading failures such as what happened in Puerto Rico after Hurricane Maria, and get impacted by weather extremes and climate change, along with other hazards such as cyber or terror attacks. From US airport networks to Indian rail networks and all the way to Boston's and London's rail systems and interconnections with power grid and water, our work shows we can benefit from a deeper understanding of failure and recovery of such network systems, especially when the understanding can lead to actionable insights. Next slide, please. In an article that we wrote for the United Nations Association of the UK, and this was joined with, this article was jointly authored with NASA and risQ, which is, so Evan here. So this was for what they call the Climate 2020 report. I'd encourage all of you to go to that website, which is listed here. So here we discussed, as shown on the top left, climate risks in the context of sea level rise and related coastal hazards combined with the value of assets at risk. Risk assessments like these are what risQ, risQ, which is the company led by Evan, does. And these can be used to embed resilience into urban systems. Here, risQ looked at Savannah, Georgia. We have also looked at, see the top right figure, how organizing principles for recovery of lifeline networked infrastructures, such as those based on network science, can potentially make the recovery faster, more effective, and less damaging. Thus, post-Hurricane Sandy, the 124 million or so of lost revenue in the New York City MTA or mass transit could perhaps have been reduced to nearly half that amount. One important practical aspect in these kinds of work is that the business model and policy aspirations almost need to be co-developed simultaneously with the science and technology advances and the development of best practices, including translations to business imperatives. This is the exact push that we believe is needed in socially impactful areas such as climate risks and infrastructural resilience. We have tried to capture that in the third figure here in the bottom left. Developing an innovation ecosystem, including cutting edge and socially meaningful startups, can help put our convergent research to practical use in the real world through novel solutions and improved best practices, as well as policy imperatives and principles. Next slide, please. So what we are proposing here in terms of translating emerging convergent research to practical and novel tools with business and policy imperatives does have many historical precedences. In areas close to what I have discussed here, the business of natural catastrophe or NatCat models was started first in the Boston area by Karen Clark about 20 to 30 years ago now, and then a few months later in the West Coast as a spin-off from Stanford by Hemant Shah. The pioneers faced similar issues with their innovative tools and methods. They would be given polite hearings by prospective buyers in the insurance sector, but the business case for the risk modeling of natural hazards, or what were then considered rare events and acts of God, were not easy to describe to a skeptical and conservative insurance companies or their audiences, or their stakeholders. However, when Hurricane Andrew struck in 1992, suddenly things changed for the industry and for Karen Clark. And not just the company AIR worldwide, but an entire line of socially impactful startups were initiated, which later became successful market leaders and altered the market dynamics, and indeed, I mean, over time helped save lives and ensured business continuity and hence economic prosperity. We can draw lessons from them, even as we think of our lab's patents and products and publications in climate risks and infrastructural resilience. And this, to some extent, I would say, is the heart of convergent research that Yang was talking about, Professor Yang Zhang. So Evan Kodra, who graduated as a PhD student from the SDS Lab and is one of our proud alums, will talk about risQ, the company that wants to help address climate risks. This company started off as a National Science Foundation small business set of grants, and now is embedded into the Intercontinental Exchange, which deals with climate risk and municipal bonds. Evan will talk more about that. Meanwhile, we have started to think of our next startups, specifically in areas such as infrastructural resilience. For example, this demo that are showing, or a screenshot from the demo that are showing for the New York City MTA. And so far, we have been calling it resQuant. Next slide, please. Coming back to the pictures, the one on the left is from Nepal. This is from inside a helicopter on my, as I was saying, on my dual cell phone camera on our way to the Mount Annapurna base camp in the Himalayas. The one on the right is from India. We are on a safari to watch Royal Bengal tigers in the wild in a place called Ranthambore. Just as an advertisement, in addition to our convergent research, we try to do a lot of experiential learning. One of them is our study abroad dialogue of civilizations program, where we have gone to various parts of the world, including India and Nepal, but also Indonesia, Brazil, Peru, etc. With that, thank you very much, and let me hand over to Evan Kodra.
Thanks so much, Auroop, and thanks for the kind introduction, Yang. So hopefully this will be a good segue from what some of the things Auroop talked about into some of the things that we do at risQ. So we can go ahead and go to the next slide, Dave. Thanks. So risQ was started in 2016 as a spin out of Auroop's Sustainability and Data Science Lab at Northeastern. We've gone through a lot of different sort of pivots and changes as time has gone on, but our mission has remained broadly the same, which is to leverage data and physical and economic sciences to figure out how to catalyze socially responsible climate investment and action all through the financial sector. And I'll go through how we got there and what we do now as well. We have a laundry list of different partners that we work with, both from the market side, including the Intercontinental Exchange, was abbreviated as ICE here, as well as others. And we've been working at this for several years. And we're at the point now where we have a pretty solid footing inside some of the financial services that drive the U.S. economy, most notably including the public finance or municipal bond sector, which I'll talk a bit about today. So next slide, please. When we originally started risQ, we actually started with the premise that we would help companies like AIR, like RMS. So when you heard Auroop talking, he was referring to Karen Clark, who was the founder and CEO of AIR Worldwide for many years. That company is still around. It's headquartered in Boston, and it's one of the top 2 companies in a market that serves the risk transfer sector. So what that means is you have a broad set of different types of organizations that help, that are tasked, that are ultimately tasked with, or trying to solve the problem of managing catastrophic risk from an insurance perspective. So we spent the first year and a half or so at risQ trying to figure out how to sell or how to get that industry through a product. So we were trying to sell a product to that industry that would help them do what we call climate conditioning to catastrophe models. So Auroop and I had spent a bunch of time talking with folks that worked at insurance companies, reinsurance companies, the modeling companies that serve those insurers, and help them figure out how much risk there is, how to manage it through premiums, and through how, what they insure versus what they don't insure. After about 18 months of working in the space, we got a lot of technical buy-in from the folks working on the science and analytics, on the modeling sides of those companies, who all really do understand that climate change is an existential threat to that sector, but to others as well. When it came time to actually doing something sort of real and commercial with that insurance sector, we never could get the ball rolling. And the short version of it was comes back to this idea that Auroop mentioned in one of his slides, which is this idea of a vicious cycle and needing to turn that into a virtuous cycle. So from a structural perspective, the insurance sector, and this is the main problem in terms of their ability to deploy climate science and change the way people deal with insurance as a function of climate change. The main reason that hasn't happened is because the insurance market as a whole is very commoditized. And every year, all the insurers and reinsurers can change their premium prices. So what happens in practice is they're all competing for market share on a price basis. So you're thinking about the kinds of things they insure. It's basically properties. So an insurer has a portfolio of properties that it insures, and it buys insurance from a reinsurer to send that risk up the chain to further, so a reinsurer has diversified its risk and has a much bigger pool of capital. But the problem is that every single entity in this system essentially writes policies on an annual basis, just like car insurance, right? You get a new premium every 6 months or every year. In this space, it's a year-long contract that you sign. So what happens in practice is that people will or companies will will sell insurance to that ultimately flows down to property owners year over year. There's not a whole lot of differentiation in what those could look like, so they start competing on price. A major event like Hurricane Katrina or Sandy happens, and all of the insurers sort of scramble to recoup their losses and jack those prices back up the next year, and then essentially year over year after that, the prices continue to fall as people compete on market share, and as people's memory of losses starts to fade. And so what that sets up is this entire system where there's no natural incentive for an insurer to say the risk is higher than it is, because they're ultimately competing on price. And so they have no appetite, at least yet, the way that market is structured, to care about climate change. It took us a long time to figure that out. What we realized as we took a step back around mid to late 2017 was that the insurance market was essentially, because of the way they do things, and they try to avoid taking a large share of high risk policies on, is that loss has to flow somewhere. And so what happens in practice is that it becomes absorbed, so that the loss or the damages from climate risk, climate catastrophes, and other natural disasters that are not related to climate, but essentially that risk all flows out and gets absorbed by the public sector. So that falls on a spectrum of the individual taxpayer to local governments, which is the key part for us, all the way up to the federal, so entities like FEMA that end up having to bail out different local governments and individuals in many cases. On the left, what you're seeing is the so-called insurance gap, which is something that Swiss Re put out several years ago. The blue line shows that is the sort of moving average global insured losses trend, and the red line is that for uninsured losses. So what this is saying essentially is that as time has gone on, the majority and an increasing share of climate disasters are being absorbed by the public sector, or at least not being absorbed by insurance. Well, that has to go somewhere, right? And so that's very fundamental to our thesis as a company. On the right, this is a quick example of something we've seen just to paint a picture of how bad this is in the US, sort of how stark the insurance gap is here. About at least 80% of flood damage in the US goes uninsured. And as flood gets worse from climate change, that's going to continue to put more and more pressure on local governments. So if we go to the next slide, please. What that means in practice is that this puts stress on the municipal finance sector in the US. So the way that this sector works, you have entities like cities, hospitals, school districts, utilities, all these different types of public entities. There are more than 50,000 of them. Issue bonds to finance critical operations, so just sort of business as usual, but also particular projects like toll roads, water infrastructure, etc. All of the infrastructure, so if you think about it, all of the infrastructure in the U.S. that's not financed federally primarily gets financed locally via municipal bonds. And bonds, you can think of those as the credit cards that all these entities use to raise funding. So investors buy those bonds with the and in return they get an interest plus a principal back at the end of the maturity of that bond, and that bond typically has a lifetime of 10 to 30 years, which makes it very sort of aligned with climate risk, right? So we know that climate risk, in 30 years is going to be significantly higher than it is right now. And up until recently, no investors in this system and no issuers in the system, or frankly any of the entities, had any good way to quantify or estimate how climate change should be impacting their decisions on whether it's worth investing in a city. So for example, the easy one to pick on is a city like Miami. And investors didn't have any tools to understand how much risk there actually is in investing in bonds for the city of Miami. And maybe this becomes more relevant to think about for those investors on the lesser known, smaller places around the US that are already stressed in terms of their ability to pay back bonds. So these are primarily small, rural, inland, or coastal towns that use bonds but already have stressed credit, and rely primarily on property values and population as their basis for paying back those debts. So property values are almost one-to-one correlated with property taxes, which are sort of the lifeline of or the backbone of every municipal debt issuer in the U.S. And climate change, because it threatens properties, also in turn threatens property values and the taxes that they can gather from those. So our mission here has become, or our goal for this market has become, to do a couple things. One is to begin to create a currency through climate risk data, much in the same way that the catastrophe modeling market did, but for the municipal bond space, to empower first investors. So when you think of investors, you're thinking of any bank in the U.S. Any bank that you could think of, household name, has some holdings in municipal bonds. It's historically considered to be a low risk investment class, and that's changing quickly. Issuers, on the back end of that, what we're hoping, or what our mission is, or goal is here, is to heighten awareness of climate risk and empower investors to make better decisions about investment, which will on the back end directly incentivize, and this comes back to Auroop's incentives point, incentivize the issuers of debt to actually care systematically about climate change. And the long goal being, if we can lend them the same currency to make decisions, then we have a system where the externality of climate change is starting to be factored in to everyday decisions, and to the actual and sort of costs are more rational as a function of that. We go to the next slide. Thank you. So what we do in practice as a company to try to solve this problem, we don't reinvent the wheel where it's not necessary. we add, we've added two key components to the classic catastrophe modeling paradigm. So we've, borrowed a lot of ideas from that catastrophe modeling space that we've talked about, where, catastrophe modeling in simple form is a function of hazard, so the actual physical risks that climate change brings, exposure, so what assets are exposed to those hazards, and then so-called vulnerability, so how exposure is impacted by hazards. And there are actual mathematical functions for that. If you have a particular type of property and a particular intensity of wildfire, you can actually estimate how much damage will be done to property, etc. What we add to this that's less conventional from a catastrophe modeling perspective are two pieces. One is we explicitly focused on climate change, forward-looking climate change. So we actually project forward out to as far as 2060 for right now, how value at risk from all of these different types of hazards will evolve under the sort of state-of-the-art IPCC climate scenarios. And that's important given that a lot of the debt issued right now in the US matures out all the way out to the years 2050, 2060 even, in some edge cases. So the alignment between timescales makes a lot of sense. The other thing that we focus on is not just a portfolio of insured buildings, right? So one of the value propositions that our customers like a lot is that we can map climate risk to any security of debt issued by any issuer in the US. And the way we do that is, rather than focusing on individual buildings, we use a combination of machine learning and geospatial data to downscale or disaggregate where we think things like property value and GDP are on a high resolution grid that gives us a flexible platform for analyzing any any debt issuer in the US, which could follow all types of different geospatial geospatial patterns or types. So you could think of that as a county with predefined boundary lines, or a hospital with a defined service area that you have to infer using GIS techniques. That's sort of the technological approach. If we go to the next slide. Just highlighting one of the key things here, we use this method called climate conditioning. Just wanted to highlight a couple of different aspects around this that sort of point to the urgency of starting to get ahead of this now. So our sort of brand new work on climate change and wildfire that we're working on with the U.S. Forest Service, we'll actually be working on some peer-reviewed articles around this topic as well, longer term. By the year 2040, and it will continue to get worse over time if fossil fuels continue to increase. At a U.S. aggregate level, we're going to see large wildfires in total will be 20 to 25% more likely than they already are today, or up to that high. So that's a really stark thing to think about. Of course, if you're obviously familiar with what's going on in California in the last few years, and actually the greater Western United States. Similarly, we're going to see the same kind of problems with inland flood. So a lot of how people conventionally think about flood in the United States is by what is a 100 or a 1 in 100 year flood risk. This is one of the less appreciated aspects of climate change. It's not just about sea level rise on the coast, because climate change, increases temperature, which in turn increases atmospheric moisture capacity. Rainfall events become more extreme, which leads to higher frequency floods or more intense floods. And so, if we're thinking of the city of Boston, and this actually happens to match what's the average for the US, by 2040, under that same scenario, what used to be a 1 in 100 year event will be a 1 in 70 year event. And so these, if as a sort of as a set of financial markets, if we don't get ahead of these types of things, when we think about municipal finance, which happens on a 10 to 30 year time scale, when we think of real estate, where the American mortgages, between a 15 and 30 year time scale, we really need to think about massive intervention and investment in understanding and pricing in, quote unquote, pricing in climate risk into how the financial markets work. We need to get ahead of this. And this is especially important given things like the insurance gap, the growing insurance gap that I was talking about before, where the insurance market just isn't set up to absorb all of these losses and risks. Next slide, please. So the other thing that I wanted to highlight, so just giving you all a quick view of what this kind of looks like in software form. So on the left, there's a screenshot of sort of a drill down in our user interface. This is Winthrop in the greater Boston area, where our clients can benchmark risk, feed that into their portfolio, compare their portfolio levels of risk to to other competitors or to a sort of average benchmark, et cetera. One of the important things, though, that risQ is hyper aware of from a social bottom line perspective is that, climate change and climate risk is really, synonymous or inextricably tied up with social justice, social and environmental justice. So one of the things that we've been pretty focused on is also quantifying for all of these cases, or for every single issuer in the U.S., how they sit in terms of their socioeconomic profiles. So that's beneficial not only from a sort of social bottom line perspective, but there is a growing demand for socially responsible investments in the market. This is so-called ESG, which stands for environmental social governance, where more and more, especially millennials and younger, are looking for 401ks, looking for things they can invest in that are actively divesting from things like oil, and actively investing in, helping communities that are, at risk and vulnerable, to help them become more resilient. And so on the next slide is sort of the punchline to all this, and where we really want to where we really want to grow risQ over the next several years. And this is on the helping the cities side of things. So, we have all these analytics that currently we have more than a dozen of banks looking at, and that share of the market is growing quickly. But on the flip side, we want to make sure we empower the issuers or the cities, et cetera, to do something about climate change, right? That way we're not actively promoting just a pure divestment from risky areas. So we actually have a proof of concept in the works right now with our partner in water engineering, water infrastructure engineering, Hazen and Sawyer, and that project is for the Boston Water and Sewer Commission. In that project, the broad idea is that Hazen and Sawyer will propose a dozen or so different potential detailed climate adaptation investments for the Boston Water and Sewer Commission that would benefit potentially benefit a variety of stakeholders. But those investments typically are incredibly expensive. So think at least billions of dollars to really build, new significant flood protection. And this is, this project is all aimed around protecting the greater Boston area under worst case scenarios out to 2070. So our role in this project is to actually take the same analytics that we use to give to investors and flip that around and say, okay, if you are Boston Water and Sewer or any other issuer in the Boston area, so the city of Boston would be another stakeholder here, for example, et cetera. How do you stand to benefit financially from this investment? And this has been one of the missing pieces in climate, in sort of climate change adaptation for quite some time now, which is the costs to adaptation are really high, but how do you prove whether an investment is worth something? And so what we plan on doing is taking those same analytics at a high level that looks at property value loss, GDP loss, and translate those into mitigated losses that you can then turn around and frame in clear conventional financial terms that then gives you an apples to apples comparison of whether the benefits of a proposed project long term will outweigh the costs, and hence that could be used by the issuer side of the market to help them raise and justify investing in climate adaptation projects. In addition, to make this play with the environmental social governance trends going on in the market, we also, and because this is incredibly important, we also plan on measuring the social impact of those same sets of investments, so that there's a multi-criteria view of whether a climate adaptation investment is makes sense both from a social justice perspective, but also from an economic perspective. And both those things ideally have to be aligned for effective climate adaptation. So that summarizes sort of the view that I wanted to get across about risq today, and I'm happy to take any questions from any folks that are interested once they see this.
Well, thank you both for excellent, very inspiring presentations and for sharing your successful story here. And let's open the floor for a panel discussion, and please feel free to submit any questions. I've received some questions already through the chat and email, and feel free to submit more and we'll try to answer them live here. And if not, we can continue the discussion offline. All right. So let me take a look at the question I have here. So the first question here, it's what is the most underappreciated risk related to the climate change in the US?
Evan, would you want to take that?
I think there are several. I think the first order, I would break them down into first order and second order risks. So first order meaning things that will happen directly from climate, and then the second order being things that will happen as a function of all those things. The first order, I would say the highest first order physical risk that people are underappreciating is inland flood. And again, that's 80 to 90% of that flood is not insured, and it's growing in terms of severity, in terms of frequency, duration. It doesn't make the news as often as hurricanes and wildfires because the shock value isn't there. But when we dig, we're seeing lots and lots of little cases of bridges collapsing, small towns going bankrupt, infrastructure failures, people without flood insurance losing their homes, or at least being deeply underwater in their mortgages, etc. In terms of second order impacts, one of the biggest things, I think that's maybe arguably the biggest thing long term for climate risk is migration. So both within the US and external, and maybe, well, most likely more importantly, external to the US. So if you're following what's going on right now in Central America, with the set of a couple of devastating hurricanes that are just hitting those places, that's certainly a strong precursor to or correlate to the need for the sort of what's going to happen around people emigrating from those places and looking for safer places to go. And unfortunately in the US, we're primarily framing this as a security issue. And so I think, the reason that's unfortunate is because it's sort of going to be an inevitable second order outcome of climate. And if we only focus on that as a security issue, what that could end up looking like is a lot more civil conflict as people are looking for safety routes. I mean, within the US, there's going to be a lot of migration, especially once sociologically something catalyzes that. That could be insurance reform, where suddenly people aren't able to get the same types of insurance policies that they could before. That's happening right now in California. Talking to a lot of people who are deciding whether they even want to live there anymore. And so that has, third order, if you want to call it, follow-on economic consequences. One of our major partners, Delta Terra Capital, is pretty convinced that, or has a hypothesis at least, that because of all this mispricing in the markets, we're going to see climate change eventually cause a financial crisis that makes the GFC look temporary and pretty small in comparison eventually.
There is one thing I'd like to add on to what Evan was saying. So, I mean, it's this point about floods was very important in the sense that we tend to overlook things that happen all the time and
Yeah.
sometimes cause more damage. One other thing, one other similar kind of extreme is heat waves, which often probably cause the most number of mortality in the U.S., especially among elderly and populations and the most disadvantaged communities. There is one other thing I wanted to just mention also, which is in terms of policy. So when we think about risk, both in academic circles and also in some political circles and media, we are often overly obsessed with attribution. We are overly obsessed with, okay, if so many people, and this is an analogy, if so many people die from cancer, is it because of smoking or is it because, I happen to live in a place where the air is polluted? And I would say that if there is good evidence that both are contributing, the air is polluted in my city, in my region, there is not that much that I as an individual can do. I can start to contribute, I can try to organize community activities. That's one thing. The smoking I can stop, right? So those are these connected things, right, which I need to work in tandem. Unfortunately, the climate risk debate has become one or the other. So it is almost inane for sometimes for us scientists, if you will, to hear these things about, is it because of climate change that wildfires are happening in California, or is it because of forest management? Well, it's not either or. You need to do both. The scales, the time scales and the ability to influence things may be different, but you do need to do both. There is no serious debate there that both are contributing, and to the extent we can stop both of these, we need to handle that. So I think that's one of the serious things about climate risk management that we all need to understand.
Well, thank you for offering great perspective. And here comes the second question. And speaking your own experience to develop initiate this startup, and it's always an exciting experience, but in the meanwhile, it involves substantial efforts. So what did you see as the major challenges and lessons learned in transforming your research to this startup? So what are the challenges and what are the lessons learned? And that would benefit many others who want to do the same thing.
Where do I start?
So Evan, while you think about this, because you have
Go ahead.
Let me just tell from a different perspective, sort of observing Evan as we go through this, and starting from, here is this patent, and we think, oh, this patent is going to solve everything. And then we were hopefully not that naive, but still we thought a little more of that patent and of the technology solution. But then, as Evan was talking about this vicious cycle, which I have tried to highlight, Evan has tried to highlight, vicious cycle of financial disincentives that exist right now, the policy myopia, which leads to, which leads to stagnation of best practices and not enough technological improvements. So this combination is what is the issue, and how the current businesses and sometimes the current software within existing businesses, like where AI or Worldwide or RMS and those kind of market leaders are in catastrophe management, and which are the specific markets that are most ready to sort of take this solution, such as Evan is now working with the real estate market, financial bonds. So it's a function of all of these, and you have to ready to start somewhere. I mean, all of us need to start somewhere, but then ready to adapt and stay flexible with the market and with what the technology can do. It's very important not to sort of offer solutions which are, which do not exist. So, smoke screens, those things do not help. And Evan, I know, has been very, very credible about that. At the same time, being flexible and trying to say, okay, this is maybe something we could do, but we need to develop further what we have. Evan, please. It is actually.
Yeah, I actually was going to say something very similar to that. I'll add that, usually if you have, in my experience from what I've seen, and this is not limited, this is for risQ, but it's also for other good ideas that I've seen happen, is that a lot of times patience, and so timing will end up mattering more incidentally than anything else. And so usually if you have a good idea, you're years ahead of you could be at least several years, especially if it's a new idea or you're trying to create a new market. You're usually, if you're doing it right, you're several years ahead of that. One practical piece of advice I have is I would definitely follow the same path that we did in terms of, I see a lot of entrepreneurs going straight, in the US at least, going straight to venture capitalists and angel investors who really want to see, with very few exceptions, want to see the billion-dollar picture. And if they don't see the billion-dollar picture, you either A, won't get funded, or you create a $1 billion picture to satisfy those investors. So I would say one of the things that helps in terms of patience is, being able to do something like NSF SBIR funding. So grant funding is actually a huge thing in the US, and there's more of it than people realize. They don't take advantage of it. Those are some of the more practical sides of these things, but agreed with everything Auroop said about needing to be flexible and sticking to your mission of what you're trying to get done, but not being married too much to the actual tactics that you think are first going to get you there at the beginning.
Well, thank you. We have a couple minutes left. Let me ask you the last question. And from the audience here, we do have some students and postdocs. So what suggestion would you have for our early career scientist engineering? How can they best prepare themselves to be a funder of climate or infrastructure startups or any startups of this kind?
Founder of startups. Evan, if you...
Yeah, talk to lots of people that have done it before. Know what you're getting yourself into first. Be sure that you're trying to start my at least perspective is make sure that you're starting a company because you want to solve a problem, not because you want to make money, because it's always more work than you think it's going to be, and a lot of late nights and all that kind of stuff. And I would also say for many people, it's probably important to do some work in industry first to understand how that actually works before you jump straight from academia into starting something. Not necessarily universal, but I think it's a helpful thing to do.
And from the curriculum education side, I'd sort of add on to that to say that, interdisciplinary. Some of the boundaries that we have created, that our generation and previous generations have created, starting from, 16th century, 17th century, 18th century, and onwards. So many of those disciplinary walls may have made sense at some point or the other. But now those same disciplinary walls will not be able to let us address problems of the 21st century and beyond. So you have to look at what are the major societal grand challenges, which aspect of those you want to solve, and which aspect of those can then be translated to industry, to solutions from the industry, from the startup. Those can be focused aspect, but they still need to relate in a big picture sense to those societal grand challenges. And then which solutions do you need for that? Those solutions or those problem spaces happen to intersect civil environmental engineering, mechanical engineering, computer science, policy, decisions, arts and media, communications. Doesn't matter. You have to have that combination of background.
Well, thank you all here, and time is up, and I hope you learned something about convergence and convergent engineering and research from today's seminar and great panel discussion here. Myself learned a lot. And we'd like to organize these events as a bi-monthly seminar. So our next speaker, 2 months from now, will be Professor Ming Wang, a distinguished professor from College of Engineering, Northeastern. He would like to share his research work with you and together with his experience for his own startup. stay tuned there. All right, so in closing, let's thank our two distinguished speakers here with a big round of applause here. And thank you both for sharing your great experience, offering tips and suggestions for all of us. Then also like to take this opportunity to thank Dave Dieter for designing wonderful lunch and learn seminar announcement for the first time, and for set up this meeting. And finally, like to take this opportunity to thank Dr. Jerry Hajar and the department head for civil environmental engineering for his great support for this initiative. I will look forward to see you 2 months from now. Thank you all. Bye-bye.